and a perfect square. How many solutions do we have? Y'all remember?
2.
2. Okay. And type, meaning what kind are they? They are real. And then, I believe we talked about this, if it's a perfect square, what did we know about those real solutions? They were also rational, meaning there was no square root in the answer. Okay? You could actually get 2 numbers as an answer. Related function, so what this means is I'm just going to draw a function. Let's say it's got roots at -2, and I'll call this 3/2. Just to prove that, you know, it's okay to have fractions, right? These are rational numbers. Okay, so if our discriminant is positive, greater than 0, but it's not a perfect square, we will still have 2 solutions. They will be real, but they will be what?
Irrational.
Irrational, meaning there will be a square root in the answer. Okay, so a sketch of what something like that might look like. Let's say we have -2√2 and +2√2. I'm just making this up, right? Just so an illustration to see, like, okay, there's 2 of them, but they're irrational. Okay, if my discriminant is equal to 0, how many solutions will we have there? 1. And it will be real, and it will be rational. Because you can take the square root of 0, it's 0. Yeah. So what that looks like graphically on a function is something whose x-intercept is also the vertex. And let's say that's -3. Okay? All right. Now we're in the set of complex numbers. Okay? If our discriminant is less than 0, if we're in the complex number system, we're not going to say no solution. There are going to be 2 solutions, but they are not going to be real. They are going to be imaginary, meaning our solutions are going to involve I. Okay? Related function, like what might that look like? Could look like a function like this that does not have a real x-intercept. Okay, I showed you all that video about I, right? Yeah. So you remember when that guy like pulled that, you remember him pulling like this plane in a new dimension and how the parabola like curved in the plane? Yeah. That has zeros, they're just in another dimension, which I can't draw, it's not possible. Okay? All right, so what we're going to do now is the same thing we did last week, where we're finding the discriminant and stating the number and type of solution. The only thing that's different is now we have an answer to these. We have an answer to these now. Okay? So I'm going to do the first one with you, and then I'll give you a couple minutes to do the other 3. All right, so we're going to find the discriminant, tell what kind of numbers the solutions will be, real or imaginary, and if they are real, tell whether they are rational or irrational. Okay, so probably need to move the -7 over so we know what a, b, and c are. So x squared minus 6x plus 7 equals 0. And then we can evaluate our discriminant. So b in this case is the number -6. So parentheses -6 squared minus 4 times 1 times 7. Okay. And Desmos is great for this because you type it one time and then all you have to do is plug in numbers. So -6 squared minus 4 times 1 times 7. Even if you're like, but I don't need to write 4 times 1. I get that, but set it up so that all you have to do is change numbers as you go. All right? So that gave us 8. So that means our discriminant is 8. So I can just say my discriminant is 8. That's a semicolon. So that's the value of the discriminant. And then what does that mean? I go up here. There are 2 real, and are they rational or irrational solutions? Irrational. Okay? 2 real and irrational solutions.
What makes it irrational?
8 is not a perfect square. So if our discriminant is positive and it's a perfect square, we're going to have nice numbers, rational numbers. If it's not a perfect square, that means that square root won't simplify all the way, so there will be a square root left in our answer. Okay? All right, y'all take a minute and answer these other 3. Okay, it's a good review. Bless you.
Just doing the discriminant?
Just doing the discriminant, not solving. Yeah, don't solve, don't solve. Don't solve.
Oh, you have to just do the
6. Sure.
Okay, if you get done before we go over it, there is like a test matching question as the next question. You can try to see if you can figure that one out. But I do want to make sure everyone has a chance to finish those. And give it like another minute or so. All right. Are we ready? These kind of were, all you had to do was change C, right? They're all the same. Okay, here's what we should have. Check yourself. Number B. Part B, discriminant was 4, so there's 2 real rational solutions. Part C, discriminant was 0, so there was 1 real and rational solution. And D, It's -8. That means there are 2 imaginary solutions. Now, you don't have to worry. When your discriminant's negative, you don't have to assess whether that's a perfect square or not. Because none of them are, right? There's no perfect square. That's only a real number issue. Those terms only apply to numbers that exist only in the real number system. So there is no irrational imaginary. That is not a thing. It's just imaginary. Yes? Why is this one irrational? Because 8 is not a perfect square. 4 is a perfect square. That's why it's rational. Okay? Okay. Let's look at a little test question here. All right. So we have 3 poorly drawn quadratic functions. Match the possible discriminant values of the related equation. So this is straight from the table that we just filled out. So which one of these, A, B, or C, would have a discriminant value of 10, positive 10? C, yeah, because there's 2 real solutions. So C would be that one. Okay, number 2, D equals 0. B, because there's 1 real solution. And of course that means A would have a discriminant of -10 because it has no real solution. All right? Okay, now we're going to go into how do you choose the best method. All right? So we have 4 methods of solving a quadratic equation, and for our purposes, we're going to abbreviate them. Okay? So square root property, SRP, quadratic formula, QF, complete the square, CTS, factoring, F. All right. Now, let's talk about just some characteristics of problems that are good for each of these. All right? So square root property. Okay, so I'm just going to go back to my notes on square root property. Let's see, I'm going too far back. Here it is. All right, example 1 from page 20. Solve by finding square roots. So this problem was appropriate for the square root property. Okay, why?
Because 4x squared is squared.
Yeah. Well, there's no bx term, right? To solve this question, and also number 1 on your quiz, all we needed to do is isolate the x squared, right? There's no bx term. So that's a clue. If I have no bx term, so I'm going to write that here. When do I use square root property? When there is no bx term. That's when I can use that one. Okay? All right. Completing the square. When should we use completing the square? Well, I think we should look at problems where completing the square was terrible. So if I go back to that notes page, solve by completing the square. Example 3 was nice. Example 4, we had to divide everything by 3, but it was still pretty nice. I mean, we had irrational answers, but that's going to happen no matter what, right? If I look at problem 5, remember this guy? And 6, remember all these fractions? This was not a good time, okay? So what about these, or let's nail it down. Let's nail example 5 down. What about example 5 made this one have so many fractions?
Like 9x is divisible by 2.
Yeah, this is not divisible by 2. So when I take half of it, it's a fraction, and when I square it, I get an even more complicated fraction. Okay? But when b is an even number, like in number 3, b is an even number, you can take that and divide it by 2 easily. Okay? So what we learned from that is I only really want to do completing the square if b is even. If b is odd, I don't really want to do completing the square. I mean, you can, but we probably don't want to. Okay. All right, now let's talk about factoring. That wasn't really in this unit, it was last unit, but it is a method of factoring, or of solving. This one's like the most exclusive though, right? You can only factor equations that will actually factor. So in other words, we can use this for trinomials that are not prime. Now, how do you figure that out, though? How do you figure out if an expression can be factored? Well, the discriminant will be a perfect square, right? Or discriminant is a perfect square. That means we're going to have two answers that are rational, okay? So the discriminant would equal a perfect square. Okay. And then lastly, we have the quadratic formula. This one is your fail-safe. This one works for all of them. But that doesn't mean it's the most efficient. Okay? I would use quadratic formula when all of these other methods are not an option. Because even though it works for all, it's also the most work. Okay? All right. So what we're going to do is we're going to take all examples 3 through 8, and we're just going to decide what method to use, and then I'll let you go and solve them, and then we'll talk about the answers. Okay? But we need to talk through the process of how do we determine what's best. Okay? All right. So let's look at example 3. X squared plus 5 equals 30. Okay? I only want to consider quadratic formula if I can consider none of these. So I notice there's no bx. So I should use what? Yep, square root property. So I'm going to write, this one is going to be SRP. Okay? Okay, if I look at number 4, so we have a bx, so I can't do SRP. So SRP's out. That one's out. Complete the square. It's kind of set up nicely for complete the square. The constant is on the right side, but do I want to use complete the square? No, because b is an odd number. So CTS is out. So now I'm down to quadratic formula or factoring. And I only want to use QF if I can't factor it. So let's see if we could factor it. Let's move the 12 over. So x squared plus 7x plus 12 equals 0. And you can either just like try to factor it. This one's pretty simple. It can, right? Or if you're not sure, well, let me bring this back. You can try the discriminant. So the discriminant, b squared, so 7 squared minus 4 times a times c. The discriminant is 1. Is 1 a perfect square? Yes. So this one can be factored. So we would do factoring on this one. Okay? All right, we go to 5. Okay, so we have a bx, so SRP's out. Let's see if we could factor it. Let's move the 6x over. So x squared minus 6x minus 6 equals 0. So you can either try to do the discriminant, or you can ask yourself, can I factor that? Are there factors of negative 6 that add to negative 6?
No.
No. So this one won't factor. What about completing the square?
Yep.
Yeah, I would definitely do that because b is an even number, so this one would be best solved by completing the square. Okay? Sometimes it's not as clear, like example 6. Right? Like, let's get that 3 on the other side so we can see it better. 2x squared plus 4x minus 3 equals 0. We know SRP is out. Let's see if it'll factor. Is it 40? Okay, so the discriminant's 40. Yeah, I remember that. If the discriminant's 40, that's not a perfect square, so it can't factor. So now we're down to complete the square or quadratic formula. What do you think? Would we want to do completing the square?
No, because 2x.
Yeah, this one's a little bit more, you have to do a little more thinking, because yes, b is an even number, but we have an a value, so you'd have to divide everything by 2, which isn't terrible, right? Because you got, I mean, you're going to have a fraction over there, but that's okay. I would say this one is probably just as equally CTS as it is QF. So that one could go either way, I would think. Because that's not terrible for complete the square, but you could also just do quadratic formula. Okay, example 7. Let me get that in standard form. Minus 8, so that'll be minus 9 equals 0. If I run discriminant on that one, b squared is 2 squared minus 4 times 5 times negative 9. Okay, so for this one, the discriminant is 184, and if I need to find out if that's a perfect square, I just square root it. Nope, not a perfect square, so I can't factor it, can't square root property. Could I do completing the square? I do have an even b, but I'd have to divide everything by 5, and once I divide by 5, so completing the square because of this 5 is not going to make this nice. So this one is just going to be QF. If everything else is too difficult, you do the quadratic formula. Okay, and what about 8? Yeah, this one's a little tricky to know because it's like a completing the square problem halfway done, kind of. But from here, it's just the square root property, because you would be taking the positive and negative square root. Okay. Also, there is no bx term visible, right? Did you have a question? You sure? Okay. All right. So now I'm going to give you about like 7 minutes. And now that we've figured out the easiest method for each one, go ahead and use that method to solve these. And then we'll check our answers in a few minutes, about 7 minutes. All right? Okay. Pause this.
Right, so it's negative 1.
So if you're ready to see kind of the solutions, here's 3 and 4. Just kind of paying attention to things that we don't want to miss, like when I apply the square root property, I need to take the positive and negative square root. Isolate square root, take positive and negative. Okay, number 4 was factorable. X plus 3 times x plus 4 equals 0. Don't forget your equals 0. And then when you apply your zero product property, each factor equals 0. So we get 2 solutions. Okay. Number 5 was complete the square. So we move the constant over to the right side. So that's a 6. Then we're going to take half of b and square it. So half of negative 6 is negative 3. Square that, you get 9. I got to add 9 over here. So I'm balancing on both sides, right? So if I add here, I add here. Now we got a PST, perfect square trinomial, so it's x minus 3 squared equals 15. Square root property, I'm going to take positive and negative square root of 15, and we can't break down the square root of 15. It's 3 times 5, those are prime. So only thing left to do is to add 3. So our answers are 3 plus or minus the square root of 15. I'm going to skip number 6 for a second. Go down to 7. 7 was quadratic formula, so making sure you've got x equals for every step, that you're not skipping steps. Okay, Discriminant of 184. 184 is the same thing as 4 times 46. 46, believe it or not, is 2 times 23, which we can't break down. 8, square root property. Can simplify the square root. Okay? Now number 6, you could have gone either way. If you did completing the square, this is likely how you would write your answer, -1 plus or minus root 10 over 2. If you did quadratic formula, which after doing both, I think quadratic formula was probably the better choice. This is how you end up writing your answer, but they're equivalent, right? Because you could separate this and be 2 over 2.
It should be -2, no? Actually? Yeah, because it's positive 4, not -4.
Oh, okay, I just wrote it. I just copied it down wrong. That should be a plus in my problem. So yeah, it'll be -2. Right, because when I did it completing the square, I got -1. Okay, yeah. Yeah. Okay, so tomorrow we have a quiz on complex numbers. We're going to review quickly. I'm not going to just give you a quiz over what we did a week and a half ago. But then pretty much this is what we're doing. Okay, we're going to practice this stuff. Yes?
Can you go back to
7, sure. Oh, I'm kind of zoomed out. Is that good? Will that work? Let me stop this.